Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Brothers Chaiken and Seth's brother, Joel Chaiken. We're here to hopefully show you how to approach SAT math questions. Here we have two math questions tied together to the same table, and this is a calculator section. Here we go. Let me make sure I'm on small mode. I'm on small mode. Okay, table. This guy is building a concrete patio in his backyard and deciding where to buy the materials and rent the tools. The table below shows all the stuff he needs from 3 different stores. Oh, wow, look at that. Okay, each store charges a different amount. The total cost Y building materials and renting the tools in terms of the number of days is given by... Wait, we have to know what M, W, and K are. Oh, I see M, W, and K. Got it. Those are the materials, the wheelbarrows, and the K. And X is the number of days. Got it. Yeah. Everything has to be defined. Okay, good. Question, and you could read it and then pause and come back. For what number of days X will the total cost of buying the materials and renting the tools from store B, be less than or equal to the total cost of buying the materials and renting the tools from store A. So you sort of have to write an equation, don't you? You have to write the B one, which is, thankfully they gave it in the same order. Oh, thank you so much. 20, make sure you read everything right. Right? It has to be less than, thanks, B less than A. Now, A is 750 plus 15 plus 65. Oh, I forgot the X. And this is the inequality to solve. Right? That's it. So I think we set it up. Did we set it up right, Seth?
Well, let me check.
Go ahead.
That's a 750.
I'm going to check also.
750 plus 15 plus 65 for A. 750, 15 plus 65. There's the X.
Right.
That X is pretty ugly.
I know. But, when you write, sometimes when you write SAT questions, it's ugly. But you have to, that's why in your brain you really have to remember this.
Okay.
Stuff. So now this is a calculator section. So now you want to try to solve this as blitzingly fast as possible. The other possibility, I guess, is to look and see the answer. It's not really obvious what the answer is. Well, we know it's always, we know it's going to be, well, we don't really know anything, actually.
So we wait. The question is, you want to find the property of X for what number of days X will the quantity we put under B be less than or equal?
Okay, fine. Yeah, but that's not. They're not.
Do it. You do it.
Okay, but it doesn't matter because they're not distinguishing that.
They might have. Yeah. Okay. They notice that all of the inequalities they gave here are in the less than or greater than equal form, but. Why not just do it accurately?
Fine. Yeah, no, you're right. No, you are so
okay,
right,
we do it accurately, period. Okay. So what we do is simply simplify the inequality. Which means get another inequality that is logically equivalent to the given inequality. Which I think you just did.
I think I did. Now, there are a ton of ways to make a mistake here. Like a million ways. There are so many negative signs here. Oh my God. I mean, negative signs are the biggest mistake you all make in algebra.
Yeah.
So, am I guaranteeing this is right? No, because there are too many negative signs in this problem.
Well, see, what you did was, to get the 150, you subtracted 750 from both sides.
That's right.
To get a constant of 0 on the right.
That's right.
And a constant of negative 150 on the left. Right. Again, please.
Seth's checking me. Thank you, Seth.
Be accurate when you're building my building. Now we simplify the coefficients. Well, first simplify, you add, simplify the coefficient. 25 plus 80 is what? 105. 15 plus 65 is 80. And now okay, cool. You put the x on the right and the constant on the left, which is smart, which is a good strategy. To get the x's on the right, we subtract 105x from 80x and get a negative quantity, and it's a negative 25 times x. So the simplified inequality is negative 150 less than or equal to negative 25. Now comes the tricky thing you have to remember, that, if you have any inequality, L is less than R. Hold on.
Painful.
If you multiply both sides by -1, the inequality sign must be shifted to the other direction. Right.
That's one of the secrets to this problem. You don't do that, you get the problem wrong.
Yeah. That's right. And you get it wrong because, see, the choices, two pairs of choices, each one is obtained from the other by switching the size, the direction of the inequality. So this is a test of this fact.
That's right.
So what you did was carefully, again, please be accurate.
Fine, but it doesn't matter.
You know what? It does matter. I'll tell you why.
Why?
Because x, they'll say L is less than or equal to R. If you negate it, in other words, say L is less than or equal to R, is false. Okay?
Yeah.
That's equivalent to L being greater than R.
Yeah.
To make it false, you change it to a strict inequality the other way. That's a place where you could get your logic messed up. That's why it's important to be accurate in distinguishing between less than or equal or less than.
Fine. I disagree in this problem. Move on.
What if they gave it? They could have given a distractor like 7 pointer.
But they didn't. Just move on.
Okay.
Just move on.
Okay. Good. So no, your point is well taken, provided that you did actually look at their responses and see that they are all.
I did.
Did you?
Yes, of course. Go back to the video.
Yeah, I knew you didn't tell me.
Well, go back to the video. I did it so fast. I did it so.
Well, okay, you did it so fast I didn't hear it.
Right.
Good. So, what's the answer?
Well, you have 6 is greater than or equal to. Okay, x. You have to split the. You have to change the sign of the thing. So it's x is greater than or equal to, I'll tell you that, x.
Yeah.
So 6 is greater than or equal to x, but my brain fries with that. Plus
which is, of course, the same, is equivalent to x is less than or equal to 6.
I don't like the way you said, of course. I don't like the way you said, of course.
No, okay, but notice, the answer is given with the x on the left.
Right.
And you wrote with the x on the right.
Right. So that's the other thing about inequalities. When you change the order of the x and the 6, you also have to change the direction of the inequality.
Yeah.
The way I think about it is I can't handle this. My brain, personally, I just literally can't digest that piece of food. It's like me trying to eat some grass. I can't digest it. I must have the x on the left because that's the only thing that makes my brain make x is less than 6. I can handle that. What is this? X greater than I can't. But anyway, the answer is this.
But what if you had a problem x equals greater than y? Greater than or equal to y, which is saying that it is equivalent to y is less than or equal to x.
By the way, I want to tell everyone now, today is a special day. It is a Feed the Seth day. And it turns
He's
out
getting hungry.
And it turns out that that is related to the question we're going to feed the Seth today.
Yeah.
So we'll get to that. We'll get to that. Okay. Yeah. Anyway, we're done. Okay, we're done.
We're done. Hey,
so here's a million ways to make a mistake. You can make a mistake in algebra. And we're not even going to bother figuring out where that.
Well, did we? Do you want to talk about why these crazy rules for inequalities are true?
I don't think so.
Or is this something we'll just leave to our audience to review from their math books?
Yeah. Because most people see this in 7th grade and 8th grade and 9th grade. They see it multiple times in their high school, middle school, and high school career. So but just by talking about it should release the cog, should remember what it is. I don't think we need to.
Well, again, if you're studying for the SAT, it's wise to review these rules that we talked about so glibly, so that they become as glib for you as it is for us.
Right, and probably the best, a really good way to do it is to take seriously the free Khan Academy study stuff. Well, the 600 questions that Khan Academy offers for free. If you do all those questions, you will have enough of this to you will practice this, and that's all free stuff. And we are not Khan Academy people. Oh, God forbid, no. We are not. We don't push anything here, right? But we just tell you what we think is a great way to study, and the Khan Academy is free, and you should use it. Okay, number 17. Ready?
Ready.
Okay.
Oh, same table. Oh,
same table. If the relationship between the total cost Y, of buying the materials and rentals from store C, and the number of days X, which the total cost of rented is graphed in the XY plane.
Yeah.
Oh, I see. What does the slope of the line represent? So they're talking about this number. What does the slope of that line represent? Y is equal to this thing plus, I always put little man X, okay? Circle plus little man X, okay?
Yeah.
Now, okay, it's fine. So it's isn't that W? It's W. What is W plus K? What is W plus K? It's wheelbarrow and rent.
Wheelbarrow and mixer.
Oh, right. Wheelbarrow plus mixer.
Yeah.
I don't see that initially here. The total cost of the project.
Yeah. So why the function that they're talking about is for store C, but it's more immediate to simply rewrite.
I think
what they told you. M plus parenthesis W plus K.
Right.
Multiplied by X.
Yeah, well, it's right there.
Now, this is in the form Y equals B plus MX.
Yeah.
Which is MX plus B. So the thing of course, M is the slope.
Right. Well, of course, but most people know that.
But the point about M and B is not that the B is on the right and the M is on the left. No. M is what multiplies X.
Right.
And B is what appears as a constant without multiplying anything. So they presented the formula that they wrote. They wrote the constant in the linear form first, and then the slope times x part second.
Right.
Okay. So notice so the slope is what's multiplying x. What's multiplying x is w plus k. W plus K, and the problem says W is the rental cost of the wheelbarrow, K is the rental cost of the mixer. Those are the tools.
Right. So you have to know
the wheelbarrow and the mixer are both tools.
Right.
And these are the daily costs so it matches response D. The daily rental costs, of the tools.
Right. Now, most people would have seen this question before in their lives. Teachers, people who make tests love to ask, what is the significance of the slope? What is the significance of the y-intercept, which is the cost of the materials? If you just get the materials, you don't buy any tools. Okay, knowing what the slope and the y-intercept represent are critical in. I'm sure everyone has seen these types of questions before, and that's what they are, right? The slope is the rate. We already talked about slope and rate are very important, and the y-intercept is the initial cost if you don't do anything, if you don't buy, if you don't start.
The rate we're talking about is the payment of rent per day.
Actually, it's right there. See, we crossed it out. We were bad people. We actually crossed out the units. See, we crossed it. They have dollars per day. You could use unit analysis to realize that as well. Do you notice also what I did is I put little symbols in. I didn't even use M and B. I used happy person. So, by the way, thanks for adding the face, the happy face, and little person. Okay, because really what it comes down to is don't get so wedded to the words M and B. Get wedded to the concepts. The concepts are the critical thing. We could call little person and little person and face all, that's what those represent, okay? Don't get, then because you're right. Some people would say, oh, it's the other way around because they're so used to the order. They memorize the formula and they don't realize maybe what this stuff means.
Yeah.
Okay. And plus you have to know what the word tools is, which is
you have to know. You have to connect. That's when they say tools, they mean those things.
Right. Yeah, that threw me for a second. Yeah. That threw me for a second. I would have liked to have said the daily cost of renting the wheelbarrow and the mixer. I would have felt better about that, but they use the word tools. So.
Yeah.
Okay. We're done?
Yeah.
I think so. So today, special treat. But anyway, goodbye, everyone. You don't have to, obviously... Don't stay for this if you don't want to. But I had a question that someone came in with, and it threw me for a loop. And be great to feed it to Seth, see how he does it, and then we'll talk about how I did it. Anyway, goodbye everyone. Have a great day. Like us, dislike us, give us comments at SAT Math Question of the Day, and please, or comment on the videos directly, and email us at that website if you have SAT Math questions. So here we go. Someone came in with this question. Number 9.14. This is for 8th grade level, an honors 8th grade level class. 9.14. This is from a book called Art of Problem Solving. I hope we don't get thrown in jail for copyright infringement. But this is nice. Let's see how Seth would do this right on, without any warning, without having the benefit of I had to go to problem 9.8 to see how it was done. But let's see how Seth would do that cold. Because this is what the kid asked me. Can you do this cold?
Okay, this is it's a proof problem.
Yeah, number 9.14.
Yeah, so X and Y are negative. Presumably, we're talking about numbers. X and Y are both negative, and X is less than Y. And then you show that the reciprocal of X is greater than the reciprocal of Y. Now, okay. The issue I have with this is I don't know what axioms were given in the textbook that you use to prove stuff. You have to, one thing. One of the rules for inequalities. Let's see, is that when you, if you have any numbers, one of the rules I know, remembered in math, one of the rules for inequalities which is, as a mathematician, I just use every day, is that, with P and Q are numbers, and they're not zero, so it makes sense to divide. And P is less than, P is less than Q. That's equivalent to the inverse of P, 1 over P. 1 over P is greater than 1 over Q.
Right, you're able to prove that.
Yeah. So that's the rule. It applies. Gosh, what if we have 1 and minus 1?
Seth, that actually is the result of 9.8. That is the result of 9.8.
Yeah. So the question is,
you can't use
I know perfectly well. So my question is, I can't begin to prove this until I know what I can use.
Well, you can't use this.
Okay, so good, great. I can't.
Presumably,
I can't use it, but they might have stated it as a postulate in the textbook, which case I can use it. I don't have the rest of the textbook.
This, they state this is a postulate. This is a postulate. They state this is a postulate.
Well,
no, they
okay. Well, and probably I can't. Again, I don't have the whole book.
Okay, let me just tell you. Ready? I believe problem, and I will show you this. Problem 9.8 proves this. Okay. So whatever use you use to prove this, you use to prove this. So try to prove this, because that's what 9.8.
Look,
I'm not. You're not going to see it, but there it is. Okay, that's the proof.
Okay, good. So the way I would approach this problem,
that's what we want.
Is look at 9.8.
All right.
Observe the strategy that they use to prove it, and then modify or simply specialize the strategy to x and y being negative and x being less than y. So my approach is look at problem 9.8 and see what they ask you to do there.
Okay, so Seth, that is absolutely 100% correct. That was like one of the points I wanted to bring in here. If you have a problem like this, I'm talking to the audience now. If you have a problem like this, don't try to just do it yourself. They're telling you go to 9.8 and read it and then see how to do it. So that actually is the approach to this problem, is don't try to be a hero and go in there and try to figure it out. You read 9.8 and then you figure it out. And believe it or not, then it's actually very doable. Okay? So that's the approach. Now,
so should we look at 9.8?
Well, as far as I'm concerned, we've met our goal, which is to show how to approach problems like this, which is to look back at the textbook and read it. Now, that's more of a college thing. In grammar school and in middle school, I don't think we never ever had to do this. I don't think we ever had problems this hard. So it's as well.
In the old days.
Yeah.
The high school curriculum included a full year of fairly carefully developed, fairly careful, not perfect, axiomatic development of Euclidean plane geometry.
Okay.
Where they made it very clear to the students that your job was to learn, what the axioms and the postulates were.
Right.
What rules of deduction were, and then a big component of the course was to write 2-column proofs.
That's not my point.
The point is this question is in the nature of what they don't teach very well now.
No, that's not my point.
No, that's a separate point. My point, one point is look at the problem that they refer to solve this problem.
When you don't know how to do something, Use the textbook.
You look at where you look it up. You look it up when they refer to, of course.
How to do it. That is the secret to this problem.
That's the secret to the problem. But what is What is the nature of the problem?
Well, you do the nature of the problem after you look up 9.8.
Yeah. We don't know what the nature of the problem is. But no. I disagree. The secret, in other words, how to do the problem when you're in the course with this textbook. That secret is obtained by looking at problem 9.8.
Absolutely.
But as a mathematical problem,
right?
You have a problem. Here's a problem. It's solving an equation. That's one kind of mathematical problem. The kind of mathematical problem this is proving something. Right? That's what I'm saying.
Yeah, but who cares really?
Really, who cares? It's mathematicians care, and my degree is in mathematics. That's why I care.
No, but that's not the purpose of discussing this. Discussing this is when you see a problem and you're not sure how to do it, go back to the textbook to see how they do it.
Okay, so you don't want to hear any more about it. Move on to the next problem.
Yeah, so now, does anybody actually want to see how to solve this? Raise your hand.
I don't see anyone raising their hands.
Okay, do you want to raise your hand? Do you want to see how they do this problem?
Write it in the comment. Maybe we'll look at YouTube.
We're not live.
Okay.
You and I are live. Okay, look, see, let's be serious. I'm sure someone may want to see actually how to solve it. Do you want to see how to solve it, Seth? Do you want to see how they do it?
Me, of course.
Okay, fine. So Seth
you're feeding me. I need food.
Raise your hand. Okay, Seth, we have one. Now, yeah, okay, good. It turns out that when you read 9.8, this problem is extremely doable. Okay. But again, this is more of a college thing, right? If you have to learn something, you have to learn it yourself. It's more of a college thing. Okay, here we go. Problem 9.8 in all of its glory. And they And they even tell you in 9.8 that in the exercise, they even warn you that in the exercise, which is our exercise, you'll be showing the reverse. So they even tell you, like a college textbook, we'll let you prove the other thing. Anyway, here we go. 9.8, go ahead. It's time to feed the Seth.
Okay. All right. Well, I'm going to... Again, I did read it.
Wow, that was...
I did read it.
That was fast.
Now, let me discuss what they wrote. Okay. We start with a little experimentation. Okay, that's a good idea to do. But that doesn't lead me directly to the mathematical question of how you prove it.
Very good idea.
Okay? And one of the principles of mathematical logic is that proving it in one single case with two particular numbers is not good enough for proving it for all values of x and y suitably restricted. Okay? So then, second paragraph, let's take a closer look. Okay, you can't see my pointer pointing to this, right?
No.
Right. So let me read this.
You can mark it up. I mean...
okay. Yeah, so I am looking at the third paragraph.
Right here.
Let us take a closer look at taking reciprocals of both sides of the inequality x is greater than y, where x and y are positive. All right. We wish to compare 1 over x to 1 over... We wish to compare 1 over x to 1 over y. And then to get the x in the denominator, divide both sides by x. So what they did was they started with x is greater than y, where x and y are both positive. And then they divide
Okay.
You divide both sides by x. Then you get a 1 on the left and y over x on the right, right? However, how do you know that when x is greater than y, you divide by x? Wait, what's... Oh, that's a y. How do you know that this is true?
Because you're dividing this.
I know, but how do you... what is the origin of the truth that if you have the inequality going this way, if you divide both sides by a positive number,
right,
the inequality stays in the same direction?
That's a great question. Don't just...
Okay, well, it's an assumption.
It's an assumption.
That is already developed. No, sorry, it's not an assumption. It's a principle or a result that was already proven in the book.
Right. Okay.
Okay, so we're allowed to use the principle. You divide both sides of an inequality by a positive number, then the inequality remains in the same direction.
Okay, moving on.
Then they do the same strategy by dividing it by y.
Right.
And you get that, which demonstrates reciprocal of y is greater than reciprocal of x, which is... so the answer is which is larger, 1 over y. Okay, good. So I'm allowed to use the principle, divide both sides by a positive number.
Right.
Okay. Now, trouble is, we need the problem at hand were for negative numbers, right? So
right.
we need to apply.
So now we can give you some space.
As an exercise, we'll show you that we reverse the inequality. As an exercise, we'll show you that we reverse the inequality when okay, we
so let's make sure that's the exercise. When x is less than y. Now notice we purposely keep the solution to 9.8 in our face when we do our problem. That's important because we're going to use the same method. Let's make sure we get it right. When x is less than y, we want to show 1 over y is less than 1 over x. We want to show, 1 over x is greater than 1 over y. Wait, let me get it right. We want to show 1 over x is greater than 1 over y. Let's double check. Check, right? The 1 over x is greater than 1 over y. This is what we want to show. This gets erased. Now we keep the solution to 9.8 in our face.
Okay.
As we do our problem.
Okay, please, there's something else I see. What is that thing your finger is on that's partially written?
In exercise? What finger?
It says important.
Oh, that's just forcing you to memorize things.
Well, what they're giving is a fact to memorize. That is given to you so that you could use it to solve the problems.
Later, but not 9.8 proof, not the exercise. The exercise specifically says don't just cite the results of 9.8.
Okay, but what's this important thing?
They're just no.
It's important. It says important.
Yes, it's important, but not for our proof.
How do you know?
Because
it's important for studying.
Seth,
okay, good. Tell me for my own for feeding me, what does the part that's cut out say?
Fine. Okay. You're my brother.
Get the book out.
You're my brother. I'll give it answer. Only because you're my brother, okay?
Yeah.
Stuff, it says stuff that if you memorize, you're going to blow your brain anyway. But you can't use it anyway in this. Okay? Fine. You want to know what it says?
Yeah.
Fine. When you're going to say, you're going to look and say, what? You're going to clog people's brains with things to memorize.
Yeah.
Hold on. Important. Here it is. Ready? I'm just going to show it to you.
Right.
Ready? Here we go. That's what it says. Is it clear?
So if X is greater than Y and X and Y have the same sign, then 1 over X is less than 1 over Y. Okay, is that all?
That's it.
Good. Excellent. So we could apply the fact that they say is important.
No, you can't. Don't you get it? You can't. That's the whole purpose of what they said. They said you cannot.
No. They say
you cannot just cite the results to prove it as we.
But they didn't. Then.
Seth, you have to prove it the same way.
Okay. All right. So, what I could do is start with. I could start with defining inequality in terms of whether a certain number is greater than 0.
Wait, stop. Can I just show you what they want you to do? Let me do it. I can't, this is painful. Let me do it. This is what they want you. It's not that hard, okay? This is not that hard. They want you to just follow.
You won't let me show you what I want.
No, of course I will. But let me go first.
Okay, go first.
This is what they want you to do. They want you to follow me, everyone. This is it. X is less than Y, and it's negative, right? You do
both
the same
of them are
thing.
0.
You
Yeah,
negative.
Both are negative.
Divide by X. So you get 1 is greater than Y over X. Because X is less than 0, you switch the sign of the inequality like the problem we just did. Now we divide both sides by Y. We get 1. Oh, Cyport froze. But everyone be patient. Seth, don't interrupt. 6 seconds. We're going to divide now both sides by Y. But Y is negative, so we switch the side of the inequality again. And then we're done. Literally, we're done. Watch. Okay, come on. Okay, here we go. Ready? We're going to start up again. We divide now both sides by Y. We get 1 over Y is less than 1 over X. That is what we are trying to prove. Now we just switch the signs. 1 over X is greater than 1 over Y.
Okay.
Done.
Okay.
Done.
Good. Excellent. Good.
Now,
The book gives you as a rule that you could apply to later problems that have an inequality. Right, have an inequality and a non-zero number. If you multiply or divide by that number or multiply by that number, both sides. If the number you're multiplying dividing by is positive, you keep the inequality direction. If it's negative, you reverse it.
No, this is more of a reciprocal thing. If X is greater than Y, then...
No. Dividing by X is the same thing as multiplying by the reciprocal of X. And reciprocating maintains the same sign. In other words, divide by X is the same thing as multiply by 1 over X.
Right.
And vice versa. Divide by... Yeah. Divide by X, it means multiply by 1 over X.
Right.
And X and 1 over X are the same sign.
Right.
So the rule is when you hit an inequality by multiplying by a negative number, you reverse the direction. You hit an inequality by multiplying by a positive number, you keep the direction.
Right.
and then you take your given, and then you apply. You did what Joel did, and you did it.
Yeah.
Okay, good.
So what were you going to say?
I was going to say the following.
Go ahead.
The following. What you need to do is I would, like this. Maybe we could move it over so I have space.
Yeah, here you go.
Okay, space. So the idea is for any X and Y.
Remember, this is what you're trying to prove.
Right?
No. This.
Okay, for all X and Y.
This is what you're trying to prove.
Yeah. X is greater than Y means X minus Y is greater than 0.
Right.
Right? So, let's see, we're going to prove. So we're starting with X. So what we're going to do is replace the symbols with other symbols so that I don't conflict with the symbols of the problem. So I'm going to rewrite this. I'm going to call this Z and W for all Z and W. Z is greater than W means Z minus W is greater. Right?
Right.
So, and now we're going to also use the rule that if N is greater than 0, minus N is less than 0.
Okay.
Okay? Now, we start with the hypothesis X is less than Y and they're less than 0. Okay?
Right.
That means from the principle 1, let's see, that means Y minus X is greater than 0.
Okay.
Right?
Right.
Now, I need to get reciprocals. Okay?
Right.
So, they're both negative. Right?
Right.
So, 1 over X is positive, and 1 over Y is positive. I multiply both sides by, so 1 over X times Y is positive. Multiply both sides by 1 over X. So if I multiply Y minus X by 1 over product XY, or I divide by Y and then divide by X, same thing. I get Y minus X divided by X and divided by Y. That's greater than 0.
Okay.
And then I distribute Y over XY minus X over XY is greater than 0.
Right.
Cancel. The Y's are non-zero and the X's are non-zero. So this all makes sense. We're not doing 0. We don't have a 0 over 0 indeterminate form. So I can cancel the Y's. I can cancel the X's and get 1 over X minus 1 over Y is greater than 0, which then finally, by our principle of what inequality means, 1 over X is greater than 1 over Y. Okay?
Right. Okay. Great.
So what I used was inequality means positive means that we have Z is greater than U. So the number line. I'm not showing the origin. I don't care whether these are negative numbers or positive numbers. If Z is to the left of W. No, sorry, I meant the other way. If Z is to the right of W, right and left.
Right.
This means Z minus W is positive, means that Z is greater than W. So I define, so if Z is to the right of W, we want Z to be bigger than W. Z to the right of W means when you go from W to Z, you go to the right, you take Z, subtract W, you get a positive number. So that's a way of defining what inequality means. Z is greater than W. What does this mean in terms of where they are on the number line and what happens when you subtract them?
You mean Z greater than? Do you mean greater than? You don't mean greater than 0.
I meant, of course. I meant, Z greater than W. Yeah, Z greater than W.
Wait, so you showed this? So you didn't even use the fact that they were negative.
That's right.
Wow, that's pretty cool. That's pretty cool.
Yeah. However, when I also used the fact that if X is less than 0, then 1 over X. Is less than 0.
Right. Now notice that you divided by.
I did. If you. Yeah.
Wait.
Which of course you get by divide both sides by X.
But you divided both sides by XY. If X and Y are both negative, then that doesn't change the sign of the inequality.
Right. That's right.
Right. Wow.
Yeah.
Wait. So that's true for both X and Y being positive or negative. If X and Y... Oh, that's right. Yeah. If X and Y are both positive or negative, then that's true.
No, wait. Something is really screwy here. Something's really screwy here. No, I made a bumbo. No, sorry. I made a mistake here. I made a bad mistake. I wrote from X is less than 0. I took the reciprocal of X. I made a bummer. Okay. If X is less than 0, the reciprocal of X is greater than 0. Yeah, that's. And if X is and Y is less than 0, the reciprocal. No, I didn't make a mistake. No, I'm sorry.
You didn't make a mistake.
Yeah. No. Okay, good. Let me just undo all this stuff. X is less than 0. Right? 1 over X is less than 0. I did make a mistake.
Wait, let me look back at that. Oh, here it is. So you're saying it doesn't matter whether X and Y are positive or negative.
In this problem. But the thing is, no, I made a mistake going from here to here. So the given problem has both X and Y less than 0. Okay? What I did was take the reciprocal of X. I originally said it's greater than 0. False. Wrong. If X is negative, then the reciprocal is also negative. Let's see that on the number line.
Wait. So in terms of the results, this is the thing. If everything's the same sign, so what you just did is you just proved number 1. You just proved the first thing. If x is greater than y, and x and y are the same sign, then the same inequality holds. That's what you just proved.
Yeah.
Okay. Fine.
Yeah.
So the only thing is that, except it in a real smart way, it turns out that in terms of answering the exercise, all you really had to do to answer the question was do what I did, which is right here.
Yes. Because apparently in this book, at the point of the exercise, they had proven, presumably, they had established that, when you divide by a positive number, the inequality stays the same.
Right.
When you divide by a negative number, you're reversed.
So the answer to this question, according to the textbook, is simply this, which is which approach-wise is really the whole purpose of our discussion here, not the details of this. The approach is that go back to the textbooks when you have a problem that you're not sure what to do, particularly when the textbook tells you to go back to the textbook if you don't know what to do. Okay? That's the because we're here more into the approach. Okay? That's the approach. And this is unusual for middle school, very unusual for middle school, to have to go back to the textbook to figure out how to do something. Because usually in middle school, you learn how to do something in school and you just do all the homework. But as you get to the higher grades, you need to do this. And when you get into college, it's all this. The professor just talks. And then in order to figure something out, you really got to sort of learn it yourself.
That's right.
Okay?
Yeah, so we went to college. In college, they give fewer easy homework questions.
Right. So that you have no choice but to go back to the textbook. At least
and
the
you're expected at college. They expect you to review and even sometimes learn new things by reading the textbook.
That's right. So this is more of a college approach question. So that's why if you're in 8th grade and this hits you like a truck, it's because this is more of a college approach.
But you said this is for an honors.
It's honors
class.
For an honors 8th grade.
Yeah.
Okay, so I think we're done.
Yeah.
Okay. Okay, everyone. Hope this.
Sorry for that mistake. that was a sloppy mistake.
Frankly, I'm not sure.
But that's why one thing when you're carefully doing math, you will fall into traps, make mistakes. That's why checking and reviewing and proofreading and doing it over and check it again is the way to have greater assurance that you haven't made a mistake.
But in terms of the mistake, your final result is still true, isn't it?
Well, that's even worse because. You didn't detect the mistake.
Right. So I don't know if anyone.
What happened was I made two mistakes and they canceled each other out.
Right. That's right. You made two mistakes and they canceled each other out.
That's not logically valid. That's two mistakes because yeah.
But that again, you didn't have to. Frankly, Seth, you didn't have to do any of that. You just could have done what I circled in green, and we would have been done. But
you would have.
I don't know. Seth has to prove it to himself, which is pretty cool. Pretty cool.
Yeah.
Okay, we have different approaches. I'm an engineer. I just want to get the answer and move on.
Yeah, well, that's why in engineering, people checking and rechecking again.
Right.
And you have to bring in, they bring in a consultant to check some more.
Right, because everybody is just obsessed about just getting the answer, not necessarily, and being a little sloppy.
Yeah.
I'm a little sloppy. That's when engineering, you're a little sloppy in engineering.
And then, of course, in engineering, what happens in engineering, it happens in many things. Is that the project may actually fail. And often, sometimes engineering projects do fail.
Yeah.
Buildings collapse.
Yeah.
And then engineers very carefully try to figure out why it collapsed and what was wrong.
Yeah.
And so they don't make that mistake again.
Right.
Yeah.
Okay, everyone, we are really done. Have a great day. And I guess we'll see you when we pick up again next week. Okay, everyone.
Next week. It's Friday.
Yeah, today's Friday. So have a great weekend, everyone, if you're watching this on Friday. If not, then have a great day. And we'll see you next time we meet. Okay, bye-bye, everyone.
Bye-bye, everyone.